Hello, members. I'm back once again, Teacher Alan, representing Pro Online, and this is our third video. We are simplifying nuclear processes. We are ensuring that this is the simplest portion of chemistry. And if you watched the first and second video, we are simplifying further this topic. In the first video, we introduced this topic and looked at the atom. In the second video, we looked at the introduction of radioactivity, or decay of unstable heavy nuclei by either emission of alpha radiations, beta radiations, or gamma radiations. So we previously, in the details, looked at alpha decay, and we are now back to have a look at beta decay. For such nuclei or atoms whose nuclei decay by emission of beta radiations, they are usually light elements. They are usually light nuclei. They are elements with very light nuclei in their atoms. So a beta radiation is simply a fast or a stream, actually a fast moving electron emitted by any unstable nuclei. So for any radioactive element to decay by emission of beta radiations, it will always emit an electron or a number of electrons so that it can become stable. And when we talk of beta decay, we shall always mean that that element or that nucleus that is emitting a beta radiation or an electron, it will always involve one of the electrons, one of the neutrons of that atom inside its nucleus being converted to a proton. This is what we are always going to call a beta decay. It will involve conversion of one of the neutrons inside the nucleus of that atom to a proton. And this kind of emission will also involve emission of energy. We said the energy may be heat or light energy. Let me think we are flowing. So for any element, for example, this is our mother nucleus. To decay by emission of a beta radiation, it will always form a daughter nucleus whose mass number is not affected, but the atomic number increased by 1, emitting an electron as the beta particle plus energy. Such elements that decay by emission of a beta radiation, they are always slightly lighter than those ones that decay by emission of alpha particles. We can take an example. So the number of electrons will also determine the extent to which this atomic number is affected. If an element emits two electrons during the radioactivity or decay, it means the mass number will not be affected, but the atomic number will be increased by 1 times 2. So the number influenced here will always greatly determine the number or the extent to which the atomic number is increased. So emission of a beta radiation will always affect only the atomic number, not the mass number. This is because during this kind of emission or decay, one of the neutrons in the nucleus of that atom will always be converted to a proton, emitting a certain amount of energy. The main thing we are talking. So these beta radiations have properties. So they have some properties. When we compare these beta radiations, we say the alpha radiations, they are helium nucleus. For these ones, they are fast moving electrons. These fast moving electrons, they will always be lighter than. So these radiations are lighter due to their low masses. The beta radiations. These ones, they will have a greater range in air compared to alpha particles. We are mentioning some of the characteristics of such radiations. These beta radiations are said to have a slightly high penetrating power compared to the alpha particles, to an extent that we shall find that these beta radiations are only can pass through even thick sheet of paper, but we shall find that it is stopped by a thick layer of aluminium. So we are looking at the different characteristics of these radiations called the beta radiations. So these beta radiations still, they are very light. We know that. Being very light, they are easily deflected by both electrical and magnetic fields. These kinds of radiations, the beta radiations, they have a less ionizing they have a less ionizing power compared to the alpha particles. We saw the alpha particles had a higher ionizing power or ionization energy, but for these ones, they ionize to a less extent. We are looking at the different characteristics of beta particles. There are more others, but we shall mention a few on which we can start to build our own work. So we can think of more examples of calculations, so long as you know that during emission of beta radiations, this becomes the mother nucleus forming a daughter nucleus. Its mass number is not affected, but the atomic number is increased by 1. So this electron becomes the beta radiation. So we can think of more characteristics of beta, as we shall get them in the books. And you can mention them in the comment section. We have more others. We cannot finish them. These ones, they have a higher wavelength compared to their alpha particles. We can talk more and more. They can still cause fluorescence or fluorescent substances. Yes, it is another characteristic, to mention but a few. They also have applications. They have applications. So the beta the applications of beta radiation emission. We can mention some of them. We shall find that these kinds of emissions or radioactivity emissions are greatly used in the medical sector. The beta radiations, or some of the elements that decay by emission of beta particles. We can mention some, such as technetium. They are used to treat cancer of bones, the bone cancer. So this is one of the applications. The technetium is used to treat bone cancer. We shall find that the beta radiations are used in carbon dating to determine the age of organic remains, such as bones. We can think of more applications, such as the medical. They are used in medical imaging, such as the PET. We know the PET, I know we've ever heard about this, which is known as the postron, the postron, the postron, such as the postron emission tomography that is used to observe the metabolic activities of a cell. So the kind of imaging they take on cells is known as the PET, the postron emission tomography. They use it to observe how the metabolism takes place in the cell. Also to detect the level of cancer in a cell or the level of the effect of cancer in a cell. I'm mentioning some of the applications of these beta radiations. We can talk of, we've ever seen this, where bags at the airport are passed under a certain machine to screen the presence of bombs and other weapons. The screening is the screening is carried out using these radiations. So it is used in security to trace for weapons. We've ever seen on regular occasions that these ones are used to trace and sterilizing medical equipment. They not only wash the equipment used for surgeries, but they also sterilize them before use to kill any microorganism that is attached to them. They use these radiations. They mostly use these radiations to preserve perishable eats. So increase their lifespan for storage. They are all applications of these radiations. We cannot finish all these the applications. They are very many. We cannot finish them. But these are some of them used to trace for radioactive additives in food, air, and water before use. We shall look at certain cases where in certain companies, they use these radioactive elements as raw materials. Before they eat their food, they always scan it or look or trace out for these radioactive elements if they were in contact with their food or in contact with the air they breathe or in contact with the water they use before they use it. It is an important procedure for their lives. And these are some of the applications. We cannot finish them. There are quite many, but these are some of them. So to compare the beta particles with alpha particles, we shall find that in terms of characteristics, these beta radiations are of great application, and we've seen some of the properties of these radiations. And I know you can sit and compare these beta radiations versus the alpha radiations. You can sit and compare them in terms of properties. They almost have related applications, but you can talk about them in terms of differences in properties. Remember, we said that the number of beta particles emitted, this number here will greatly determine the extent to which the atomic number of the daughter nuclei is affected. So with all that, I think we are good to look at the gamma decay, if you don't mind. We am Online. Don't forget to subscribe and invite friends.